On this slide, we're starting our exploration into authentication attacks within the scope of the CompTIA PenTest Plus PT0-003 certification course. Understanding authentication attacks is crucial for penetration testers, as attackers often target authentication mechanisms to gain unauthorized access to systems. By mastering these attacks, you can better assess the strength of current authentication protocols and recommend improvements to enhance security. This knowledge will not only help in discovering vulnerabilities, but also in fortifying defenses against real-world attackers. Now, let's move on to the next slide, where we will dive into multi-factor authentication, MFA fatigue. We'll cover what MFA fatigue attacks are, their impact, and techniques for simulating such attacks to test the robustness of MFA implementations. Additionally, we will discuss an example of simulating multiple login attempts to trigger MFA fatigue, enabling a thorough understanding of how to identify and exploit these vulnerabilities during your penetration testing engagements. On this slide, we delve into a prevalent issue in modern authentication security, multi-factor authentication, or MFA fatigue attacks. First, let's define what MFA fatigue is. It occurs when legitimate users are bombarded with continuous authentication requests, causing them to eventually approve one out of frustration or confusion. This can significantly undermine the security benefits of MFA. Understanding the implications of MFA fatigue attacks is crucial for penetration testing because these attacks target a fundamental defense mechanism against unauthorized access. By simulating these types of attacks, penetration testers can evaluate and highlight the effectiveness of an organization's MFA implementation and identify susceptibility to such fatigue techniques. From a practical standpoint, one common technique to perform an MFA fatigue attack is by automating multiple login attempts. The aim is to continuously prompt the MFA challenge until the user becomes so overwhelmed that they, perhaps inadvertently, approve the request. Next, we'll move on to discuss pass-the-hash attacks, including definitions, risks, and how tools like CrackMapExec can be used to simulate these scenarios. Let's continue with our course presentation. In the previous slide, we discussed multi-factor authentication, MFA fatigue, its definition, the impact it can have on an organization, and techniques attackers use, such as simulating multiple login attempts to exploit this fatigue. Now, in this slide, we will delve into pass-the-hash PTH attacks. Firstly, let's define what a pass-the-hash attack is. Essentially, PTH involves capturing and using the NTLM hash of a user's password to authenticate without needing to crack the hash or even know the actual password. This attack is particularly dangerous because it allows an attacker to bypass the need for plain text credentials altogether. Secondly, we will explore the risks associated with pass-the-hash attacks. One of the primary risks is that once an attacker has gained the hash, they can move laterally within a network, accessing multiple systems without detection, potentially leading to significant data breaches. To perform a pass-the-hash attack, attackers typically leverage tools like CrackMapExec, CME. For instance, using the command CrackMapExec SMB 192.168.1.24 -u user-h AA3b 435b 5144 EADB 435b 51404E, attackers can authenticate against a set of systems within the specified IP range using the captured hash. Next, our upcoming slide will introduce pass-the-ticket attacks, including their definitions, techniques, and practical examples using tools like Mimikatz. We'll see how an attacker can present a pre-authenticated Kerberos ticket to access resources within a network. Let's move on to slide 4. Continuing from our previous discussion on pass-the-hash attacks, let's now move on to another common attack vector, pass-the-ticket attacks. Pass-the-ticket attacks involve obtaining a Kerberos ticket and using it to access network resources. These tickets, once acquired, allow an attacker to impersonate the ticket holder, which can be extremely damaging as it enables access to various resources without needing the original user's credentials. The techniques for executing a pass-the-ticket attack often involve tools like Mimikatz. Here's a practical example using Mimikatz to perform a pass-the-ticket attack. The command Mimikatz Kerberos ptt-ticket.kirby is used to inject a Kerberos ticket into the current session, effectively allowing you to assume the identity linked to that ticket. We'll further discuss the details and mitigations for pass-the-ticket attacks, but first, let's proceed to the next slide, where we will delve into pass-the-token attacks, another critical vector to be aware of in securing your systems. On the next slide, we'll explore the definition and impact of pass-the-token attacks, techniques to carry out these attacks, and an example using the tool Rubius with the command Rubius PTT/ticket base 64 ticket. Let's move on. Slide 5 focuses on pass-the-token attacks, continuing our exploration of credential theft techniques. Like pass-the-ticket attacks, pass-the-token attacks allow an attacker to impersonate a user without needing their plaintext password. First, we define and understand the impact of these attacks. Pass-the-token attacks involve capturing and reusing authentication tokens, which can grant unauthorized access to systems and data. These tokens can often provide higher levels of network access, especially if the compromised token belongs to an administrator or a privileged account. In terms of techniques, various tools and methods can be used to execute pass-the-token attacks. One notable tool is Rubius, a powerful tool for Kerberos interaction and abuse. Rubius can manipulate Kerberos tickets to escalate privileges or move laterally within a network. As an example, let's consider how Rubius is employed in a pass-the-token scenario. The command Rubius PTT/ticket base 64 ticket. Here, the attacker inputs a base 64 encoded Kerberos ticket they have intercepted or forged. The PTT command in Rubius effectively passes this ticket, allowing the attacker to impersonate the user linked to that token and gain access to resources under that user's permissions without needing their password. In our next slide, Slide 6, we'll delve into Kerberos attacks more broadly, discussing various techniques and tools like Kerberoot used for Kerberos-based attacks, and understand how these methods can potentially exploit weaknesses in Kerberos authentication. Building upon our discussion of pass-the-token attacks, now we'll delve into Kerberos attacks. Kerberos is a widely used protocol for network authentication, often targeted due to its critical role in managing access to services. There are several attack vectors that can be exploited within Kerberos, making it a juicy target for attackers looking to gain unauthorized access within a network. Let's discuss some techniques for Kerberos attacks. One common method is brute forcing Kerberos accounts. This involves generating a large number of authentication attempts to discover valid usernames and sometimes even passwords. A tool that is frequently used for this purpose is Kerberoot. For example, you can utilize Kerberoot to enumerate users in a domain with the following command: Kerberoot user enum d domain.com dc 192.168.1.10 userlist.txt. Here, user enum instructs Kerberoot to enumerate users, -d-domain.com specifies the domain, -dc 192.168.1.10 identifies the domain controller, and userlist.txt contains a list of potential usernames to be tested. Understanding these attack techniques and their mitigation strategies is vital for strengthening the security posture of networks employing Kerberos. In the next slide, we will explore LDAP injection. Slide 7. LDAP injection. Continuing from Kerberos attacks, let's now dive into LDAP injection. LDAP, or Lightweight Directory Access Protocol, is widely used for directory services authentication, and it is crucial to understand the vulnerabilities associated with it. LDAP injection is a form of attack similar to SQL injection, where an attacker can manipulate the input to gain unauthorized access to directory services. The impact of such an attack can be severe, ranging from unauthorized access to the modification of sensitive information stored within the directory. Different techniques can be utilized to perform LDAP injection attacks. One common method involves injecting LDAP filter syntax into the authentication forms. For example, by using Burp Suite, an attacker can observe and tamper the data being sent to the LDAP server. They might inject a payload like user_admin, password_, which tries to match any user input due to the wildcard operator. In a practical scenario, an attacker using Burp Suite would intercept the request and inject the crafted payload to bypass authentication controls, thus gaining unauthorized access. Understanding these methods is essential for both offensive and defensive security measures. In the forthcoming slides, we will look at other attack vectors, such as dictionary attacks, to widen our perspective on commonly used attack methodologies. Slide 8, Dictionary attacks. Now that we've covered LDAP injection attacks, let's move on to dictionary attacks. A dictionary attack is a method of breaking into a password-protected system by systematically entering every word in a predefined list or dictionary to find the right match. For our example, we'll use a popular tool called Hydra. Hydra is a versatile and powerful tool that allows us to perform dictionary attacks across multiple protocols, such as HTTP, SSH, and many others. Here's a basic command to perform a dictionary attack using Hydra. Bash Hydra del usernames.txt-p passwords.txt 192.168.110 http form post/login. In this command, -l usernames.txt specifies the file containing a list of usernames. -p passwords.txt specifies the file containing a list of possible passwords. 192.168.1.10, the target IP address. HT form post/login indicates that we're aiming at the login form for an HTTP service. Hydra will systematically try every combination of usernames and passwords from the provided files to gain access to the target system. In the next slide, we'll delve into brute force attacks, which are somewhat similar but more exhaustive in their approach. Let's move on to slide 9 for a detailed look at brute force attacks. Slide 9, brute force attacks. Now let's move on to brute force attacks. A brute force attack systematically guesses all possible combinations to find a password or encryption key. It's a more exhaustive method than a dictionary attack, aiming to try every possible combination until the correct one is found. This approach can take considerable time depending on the complexity of the password and the computing resources available. In terms of techniques, a brute force attack requires a lot of computational power and time, making it less efficient against highly secure systems or complex passwords. However, with advancements in GPU and cloud computing, the time required has been significantly reduced for simpler passwords. Here's an example of a brute force attack using a popular tool called Medusa. Medusa H192.168.1.10 -u-admin-p passwords.txt mssh. In this command, -h192.168.1.10 specifies the target IP address. -u-admin sets the username for the brute force attempt. -p passwords.txt points to the file containing the list of passwords. -mssh notes the specific service being attacked, in this case SSH. By employing this method, Medusa will attempt every password from the list in passwords.txt on the specified SSH service for the given username. Next, we'll explore mask attacks, which enhance the efficiency of brute force techniques by applying specific patterns and rules. Slide 10, mask attacks. In this slide, we're shifting our focus from brute force attacks to mask attacks. A mask attack is a more sophisticated form of brute forcing that leverages patterns and constraints to reduce the number of possible passwords to be tested. Instead of trying every possible character combination, mask attacks can focus on more probable passwords. To illustrate, let's use the Hashcat tool, which is renowned for its effectiveness in performing various types of attacks, including mask attacks. The command on the slide shows how you would configure Hashcat to perform a mask attack. Shell hashcat-0 mate3 hash.txt d. Breaking down this command, Deichembro specifies the hash type, in this case MD5. -a3 indicates that we're using a mask attack. Hash.txt is the file containing the hash we want to crack. .dd is the mask where .d represents a digit, 09. So our mask attack is targeting passwords that are exactly 4 digits long. This method is particularly useful for targeting password policies you might be aware of, making the attack both faster and more efficient compared to a standard brute force attack. In our next slide, we'll explore password spraying attacks, discussing their impact and techniques. On the previous slide, we discussed mask attacks, a method used to guess passwords based on a fixed pattern. We also saw an example using Hashcat for a mask attack where we specifically targeted 4 digits. Now let's move on to password spraying. This type of attack involves attempting a single or small number of commonly used passwords across many different accounts, rather than targeting a single account with a list of passwords. The impact of password spraying can be quite significant, as it leverages users' tendency to use weak and easily guessable passwords. To perform a password spraying attack, one might use tools such as crackmap.exec. For example, you can use the following command to perform a password spraying attack in an SMB network environment. crackmap exec SMB 192.11-24-users.txt-p password 1. Here, 192.168.1.0/24 represents the subnet you are targeting. Users.txt is a file containing a list of usernames, and password 1 is the password being tested across these accounts. Next, we'll continue our exploration of attack vectors with credential stuffing. We will define what credential stuffing is, discuss its impact, and go through techniques for performing such attacks. We will also look at a practical example using the sniper tool to demonstrate credential stuffing attacks. Slide 12, credential stuffing. Continuing from our discussion on password spraying, let's shift our focus to another prevalent threat, credential stuffing. Credential stuffing refers to the use of automated tooling to test a large volume of username-password pairs, often obtained from previous data breaches, against various online services. The impact of credential stuffing can be severe, resulting in unauthorized access to user accounts, data breaches, and potential financial losses. To perform credential stuffing attacks, attackers typically use tools that automate the process. For this example, we'll be using Sniper, a tool designed for such purposes. The command sniper-t target.com-mcreds is an illustration of how to test a target domain with stolen credentials. In the next slide, we'll explore OpenID Connect, OIDC attacks, examining the attack vectors and techniques used to exploit weaknesses in OIDC implementations. Now, moving on to OpenID Connect, OIDC attacks. In this slide, we'll delve into the intricacies of OIDC authentication and the various vectors through which attacks can be conducted. OpenID Connect is an identity layer on top of the OAuth 2.0 protocol. It's designed to be secure, but as with any protocol, misconfigurations and vulnerabilities can be exploited. First, we'll provide an overview of how OIDC authentication works and the potential attack vectors. This includes things like token substitution, replay attacks, and improper validation of tokens. Second, we will discuss techniques for performing OIDC attacks in a controlled environment. This will help you understand the potential weak points and how attackers might exploit them. Lastly, we'll go through an example of exploiting OIDC misconfigurations using Burp Suite. This hands-on demonstration will provide you with practical insights into how these attacks can be detected and mitigated. By the end of this slide, you should have a deeper understanding of OIDC attacks and the skills to assess and secure OIDC implementations in your own environment. Let's continue to the next slide, where we'll explore SAML authentication and its associated attack vectors. Let's now shift our focus to SAML attacks on slide 14. As we previously discussed OpenID Connect, OIDC attacks, where we covered authentication and various attack techniques using tools like Burp Suite, we'll now dive into the world of SAML. Starting with an overview, SAML, or Security Assertion Markup Language, is another standard used for authentication and differs from OIDC in its approach. Like OIDC, SAML is vulnerable to various attack vectors. We'll talk about specific techniques used to perform SAML attacks. These can involve manipulating SAML responses, replay attacks, and other advanced methods that can compromise authentication. To illustrate this, we will walk through a practical example of exploiting SAML response manipulation using Burp Suite. This hands-on example will demonstrate how misconfigurations and improper handling of SAML responses can be exploited to bypass authentication mechanisms. In our next slide, slide 15, we'll provide an overview of the tools used for authentication attacks and discuss the importance of selecting the right tool for each type of attack. This will help you better understand the toolset available and how to leverage them effectively. Slide 15, Tools Overview. In this slide, we will discuss the various tools used in authentication attacks. It's critical to understand that selecting the right tools is essential for the success of each specific attack type. These tools are designed to exploit different vulnerabilities in authentication systems, and their effectiveness can vary depending on the context and the targeted entity. We'll go through some of the widely used tools in the industry, their purposes, and how they can be applied in different scenarios. By the end of this section, you should have a clear understanding of which tools are best suited for your needs when performing authentication attacks. Moving forward, the next slide will delve into crackmap exec, CME, a powerful tool for orchestrating various authentication attacks. including the pass the hash technique. On this slide, we're focusing on CrackMapExec, or CME, which is a robust tool widely used in authentication attacks. CrackMapExec excels in facilitating post-exploitation scenarios, allowing for automation and streamlined processes during penetration testing. First, let's talk about the general overview of CME. It's an open-source Python-based tool designed to help ethical hackers perform both vulnerability scanning and exploitation tasks, specifically targeted at SMB servers. One of its key strengths lies in its versatility and the ability to integrate with other tools. Next, we examine some essential techniques for using CME effectively. It can be utilized to conduct various types of attacks, such as pass the hash, passing credentials, and spraying passwords. The flexibility of CME means it can handle complex attack methodologies with relative ease. As an example, consider using CME for a pass the hash attack. In this scenario, you might use the command shell crackmapexec smb 192.168.1./24 u user HAAD3435B514EADB435B51404E. In this command, you're instructing CME to target the SMB protocol within the specified IP range, 192.168.1.24, with the username user and the provided NTLM hash. This allows you to effectively test for vulnerabilities related to NTLM authentication within that network range. We'll see similar tools and techniques in the following slide where we explore Responder. Now let's move on to understand how Responder can be used to capture NTLM hashes efficiently. On this slide, we're going to dive into the Responder tool, another powerful utility in the network attacker's toolkit. To begin with, Responder is a tool designed to poison name resolution requests on a local network, enabling an attacker to capture valuable authentication data, such as NTLM hashes. For techniques, Responder takes advantage of weaknesses in network protocols like LLMNR, Link Local Multicast Name Resolution, and NBTNS, NetBIOS Name Service. By intercepting these requests, Responder can masquerade as the desired network resource and gather credentials that are transmitted during this process. Let's look at an example to understand its practical use. Suppose we want to capture NTLM hashes on our local network interface eth0. The command would be responder-i eth0. By running this command, Responder starts listening on the specified network interface, intercepting and poisoning traffic to capture those valuable NTLM hashes, which can then be analyzed and potentially cracked using tools like Hashcat, which we will discuss on the next slide. In our subsequent lesson, we'll explore Hashcat, a robust password cracking tool that can use these captured hashes effectively to retrieve plain text passwords through various attack methods. Now that we've covered the basics of using Responder for capturing NTLM hashes, let's move on to another essential tool in the penetration tester's arsenal, Hashcat. Hashcat is a highly effective password cracking tool that supports a wide variety of attack modes and hash types. In this slide, we will delve into the specifics of using Hashcat in authentication attacks. Firstly, we'll cover the overview of Hashcat and its capabilities, including the types of hashes it can crack and the different modes of attack it supports, such as dictionary, brute force, and hybrid attacks. Next, we will examine some techniques for effectively using Hashcat in authentication attacks. This includes selecting the appropriate hash mode, optimizing performance with GPUs, and fine-tuning attack strategies for faster and more accurate results. As an example, we'll demonstrate a dictionary attack using Hashcat. In this scenario, we will use a predefined word list against a set of captured NTLM hashes. The command hashcat m1000-0 hashes.txt wordlist.txt will be used for this purpose. Here, NISM1000 specifies the NTLM hash type, NISA0 indicates a dictionary attack, hashes.txt is the file containing the hashes, and wordlist.txt is our wordlist file. By the end of this section, you should have a solid understanding of how to leverage Hashcat for effective password cracking, enhancing your capabilities in performing authentication attacks. Next, we'll proceed to explore another powerful password cracking tool, John the Ripper. Similar to Hashcat, John the Ripper offers a variety of techniques for breaking passwords, which we will examine in detail. Now that we have covered Hashcat and its capabilities, let's move on to another powerful password cracking tool, John the Ripper. John the Ripper, often referred to simply as John, is a highly versatile password cracking tool that's used in various authentication attacks. Like Hashcat, it's designed to identify weak passwords within a system and can be used to assess the strength of passwords across different password formats and hashes. When using John in authentication attacks, there are several techniques you can employ. These techniques range from simple dictionary attacks to more complex brute force attacks. With its extensive configuration options, John can be customized for different cracking needs and optimized for speed. For example, a common use case for John the Ripper is performing a brute force attack. The command for this would look something like this: bash John wordlist equals passwords.txt hashes.txt. In this command, -wordlist equal passwords.txt specifies the word list containing potential passwords, and hashes.txt is the file with the hashed passwords we're attempting to crack. By leveraging a comprehensive word list, John attempts to match each password in the word list against the hashes. John the Ripper is particularly known for its speed and efficiency, making it a preferred choice for many penetration testers and security professionals. Its ability to support a wide variety of hash formats adds to its robustness as a password cracking tool. Next, we will delve into Hydra, another essential tool in the password cracking toolkit. Moving on from John the Ripper, let's now focus on another highly effective password cracking tool, Hydra. On this slide, we'll start with an overview of Hydra. Hydra is a fast and flexible tool that supports various network protocols, making it ideal for penetration testers and cybersecurity experts when they need to brute force login credentials. With its ability to perform parallelized sprawling attacks, Hydra stands out for its speed in comparison to other tools. Next, we'll discuss techniques for using Hydra in authentication attacks. Hydra can target forms, web login pages, and a wide range of network services, including FTP, SSH, and Telnet, among others. The tool uses a combination of username and password lists to try and break into accounts by submitting numerous login attempts. For instance, let's examine a specific example, using Hydra for an HTTP form brute force attack. In this case, you might use a command like hydra-l usernames.txt-p passwords.txt 192.168.1.10 HTTP form-post/login. This command tells Hydra to read potential usernames from usernames.txt and potential passwords from passwords.txt. It will then target the IP address 192.168.1.10, specifically the HTTP form, making attempts to log in at the /login endpoint. Now that we've covered Hydra, let's prepare for our next discussion on Bloodhound, where we'll dive into using this tool for mapping Active Directory attack paths and understanding its capabilities in a broader network context. Continuing from our previous discussion on Hydra, now let's shift our focus to Bloodhound. Bloodhound is an invaluable tool in the context of Active Directory AD security. This slide will provide an overview of Bloodhound, highlighting its capabilities and techniques for employing this tool effectively in authentication attacks. Bloodhound is primarily used for mapping out and visualizing relationships within an AD environment. This makes it an excellent tool for identifying attack paths and potential vulnerabilities that an attacker might exploit. Unlike traditional password crackers, Bloodhound does not brute force credentials. Instead, it helps attackers and defenders understand privilege escalations and lateral movements within an AD infrastructure. For instance, by leveraging Bloodhound, you can identify user accounts that have administrative privileges across multiple machines, or determine which users can reset passwords for other high-privilege accounts. This makes it possible to strategically plan authentication attacks, such as compromising lower privilege accounts that may eventually lead to higher privilege access. Now let's look at a practical example. Imagine you're using Bloodhound to assess an AD environment. The tool can enumerate and analyze various relationships, such as group memberships, ACLs on AD objects, and sessions on machines. This can give you a clear picture of attack paths, helping you pinpoint where to focus your efforts. In the next slide, we will explore Medusa, another powerful password cracking tool, and see how it can be employed for specific authentication attacks, like SSH brute force attacks. Now, let's delve into another powerful tool for authentication attacks, Medusa. Medusa is an open-source, modular, and versatile password cracking tool. It allows for dictionary-based attacks against a wide range of services and protocols, making it a staple in many penetration testers' toolkits. When using Medusa in authentication attacks, its primary aim is to brute force login credentials. Medusa supports parallel network login brute forcing, which enhances the speed and efficiency of the attacks by attempting multiple username and password combinations across various hosts. To give you a practical example, let's consider a scenario where we need to perform an SSH brute force attack on a target host with the IP address 192.168.1.10. Suppose we have identified the username admin and compiled a list of potential passwords in a file named passwords.txt. You can execute Medusa with the following command: Medusa 192.168.1.10-u admin-p passwords-ext m ssh. In this command, -h specifies the host to target. -u defines the username to be used. -p points to the file containing our list of potential passwords. -m indicates the module, which in this case is SSH. This will initiate a brute force attack attempting each password in the list against the SSH service for the admin, username on the specified host. Up next, we will explore Burp Suite, a comprehensive web vulnerability scanner. We will look at how Burp Suite can assist in authentication attacks, specifically focusing on performing LDAP injection attacks. See you in the next slide. Now that we've looked at Medusa and its capabilities for conducting password cracking attacks, focusing specifically on our example of an SSH brute force attack, it's time to shift gears and discuss another powerful tool, Burp Suite. Burp Suite is a comprehensive web vulnerability scanner that allows security professionals and penetration testers to identify and exploit vulnerabilities in web applications. One of its core functionalities is its ability to perform authentication attacks effectively. This includes techniques such as credential stuffing, brute force attacks, and more sophisticated attack vectors like LDAP injection. For example, let's consider using Burp Suite for an LDAP injection attack. In this attack, we might send a crafted request like user=admin, password=* to manipulate how the backend parses the LDAP query. Burp Suite's intruder and repeater tools make it easy to test a variety of payloads and conditions, streamlining the process of identifying weak points in authentication mechanisms. We'll dive deeper into some practical use cases and best practices for leveraging Burp Suite in these types of attacks. Next, we will summarize our findings and discuss the importance of mastering these tools and techniques to enhance your penetration testing skills. Stay tuned as we move on to our conclusion and review in the next slide. On this slide, we will conclude our exploration of authentication attack techniques and tools. Over the course of this module, we've delved into various methods for exploiting authentication mechanisms, using tools like Burp Suite to carry out sophisticated attacks, such as our example on LDAP injection. To summarize, mastering these techniques is crucial for any penetration tester. Understanding how to effectively use tools like Burp Suite can significantly enhance your ability to identify and exploit vulnerabilities. This knowledge not only aids in uncovering security gaps, but also strengthens your overall effectiveness in penetration testing. As we move forward, I encourage you to continue practicing these techniques. The landscape of cybersecurity is ever evolving, and staying sharp in your skills is key to maintaining a high level of proficiency. From here, further learning and hands-on practice with these tools will be invaluable.